In this collab, we're going to look at TensorFlow Hub. TensorFlow Hub is a library of already pre-trained models that we can use for transfer learning. But before we start, let's follow the instructions here and reset our runtime. Let's also make sure we're using Python 3 and GPUs. To execute this collab, we need to install a specific version of TensorFlow. We're also installing TensorFlow Hub. Then we do our imports. You can see that we use TensorFlow, TensorFlow Hub, and TensorFlow datasets. Okay, import number 1 will reuse an entire model in TensorFlow Hub to try things out. This model is called MobileNet V2 and can be accessed from TensorFlow Hub using this URL. MobileNet expects color images that has the input resolution 224 by 224. And here's our entire model, just a single hub Keras layer that wraps the model URL and the resolution. To try this model out, let's load an image called Gracehopper from the internet. We also resize it to the resolution expected by MobileNet and normalize the pixel values to be within the 0 to 1 range. Now, let's do the prediction. Observe that we're adding one dimension to the image. This is the batch dimension. The predict call always expects a batch dimension. Since we're predicting a single image, we get one result back with the probability distribution across 1001 classes. The reason for this is that MobileNet has been trained on a dataset called ImageNet, which has 1001 classes. Here, we pick the class index with the highest probability. So the predicted class is index 653. But what is actually this class? To find that out, let's download the ImageNet class labels. And then we can print the human readable label at this index. Bingo! The prediction is military uniform. Now, let's move to part 2 and see how MobileNet performs on the cats versus dogs dataset. Let's first load the dataset using TensorFlow datasets. As we know, these images have different resolutions. So let's create a function that resizes them all to 224 by 224 pixels and also normalizes the pixel values to be between 0 and 1. We apply this transformation by calling the map function here. Let's also shuffle the training dataset and specify the batch size. The prefetch parameter here is just an optimization.